All right, guys, we got one more rule. All right, guys, we got one more rule. This is the last rule. This is called trapezoidal rule. And we're going to find area of trapezoids. So you guys probably recognize trapezoids as looking like this, where this is base 1, base 2, and you got some height. So area of a trapezoid is height times base 1 plus base 2 divided by 2. So our trapezoids are going to look like this. So we're going to have a curve. And let me go ahead and put the trapezoids in blue. Point here, point here, point here. And our trapezoid is going to look like that. So our height, quote unquote, our height is going to be our delta x. See? And our base, y0, y1, y2, y3, are going to be these y values. Do you guys see that? And in case you're wondering, you're only going to use this formula when the bases have equal delta x's. You'll see in the future we're going to have problems where the delta x is rarely ever the same for all of them unless we're equal spacing. So, Chav, what are you talking about? Well, look, I'm going to call this trapezoid 1, trapezoid 2, trapezoid 3. If I wanted the area of those three trapezoids, you would do this. You would say, okay, area. And usually a T stands for trapezoidal. And you would say y0 plus y1 times your height, which in this case, we're going to say all three of these are equal delta x's. Delta x divided by 2. Plus, for the trapezoid 2, you're going to go y1 plus y2 times delta x divided by 2. Plus y2 plus y3 times delta x divided by 2. I know, guys, I'm sorry. I should have put it on the right-hand side. All right, remember, look what we said. That we said that delta x is the same as height. So I can rewrite this area of the trapezoid as, I'm going to write y0 plus y1 times h over 2 plus y1 plus y2 times h over 2 plus y2 plus y3 times h over 2. Yes. T for trapezoid. What do all three of these terms have in common? H over 2. So notice, and I'll zoom out right here. I can do this. Area of trapezoid equals h over 2 parenthesis y0 plus y1 plus y1 plus y2 plus y2 plus y3. All I did was take out the h over 2 and drop the parentheses. Next, notice how many y1s do you see? How many y2s do you see? H over 2 parenthesis y0 plus 2y1 plus 2y2 plus y3. And OMG, look at that. We got that formula there. So you don't have to memorize it, guys. You can just derive it from scratch. I actually prefer that we do derive it from scratch every time, especially if it's in the table. That way you never make a mistake. But if you're in a hurry, you can always do it. If you have 3 trapezoids, you're going to need 4 points. 1, 2, 3, 4. If you have 4 trapezoids, you're going to need 5 points. If you have 5 trapezoids, you're going to need 6 points. And then your endpoints do not have a 2 in the front. See? They don't have a 2 in the front. It's all the interior points that have a 2. Cool or not cool? All right, guys. So that's just how you know it. By the way, trapezoid is the same thing as taking an LRAM and an RRAM divided by 2. You get the same results. Last year, Ms. Guerrero thought that doing this route was the easiest route. That's fine. If you think that's easier, do that. It's not a big deal. Both are the same. Not a big deal. All right. You guys ready? We're just going to go right into it. It's not that bad. I'm going to exaggerate it. It says use the trapezoidal rule where n equals 4. So that means 4 trapezoids, 4 traps, to estimate the area of the curve from 1 to 2 of x squared. So here it is. I'm exaggerating x squared, guys. I'm exaggerating it. I'm going to say here's 2. And I'm going to say that here's 1. So if they want 4 trapezoids, so I'm going to go boop, boop, boop. 1, 2, 3, 4. Okay, don't worry. Yeah, all the delta x's are 1/4, right? Because you have 4 trapezoids. 2 minus 1 divided by 4. All right, check it out. Put a point, boom, and put a point. You're going to go boom, boom, boom. Point. 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 Trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4. We still okay? All right. The delta x of each one of these trapezoids, which is your height, is 2 minus 1 divided by 4, so 1/4. You guys didn't need to do the calculation. You already knew that. From 1 to 2, each one of these trapezoids is 1/4. But it's good to show it. Area using trapezoids, using 4 of them, 1/4 height divided by 2, open parenthesis. Chav, what are you doing? I'm doing this. I'm doing this. The very first y value is at 1, and it's a squared. This is my function. 1 squared. I need 5 points plus 2 times 1.25 squared. Does everyone know how I got 1.25? Okay, just in case, remember that your delta x was 1/4. So I added 1/4 to 1. Plus 2 times 1.5 squared. Plus 2 times 1.75 squared. Is my last point going to have a 2 in the front? No. Just 2 squared. I don't have my calculator with me anymore, at least at the moment. So you guys are going to have to help me out because my calculator doesn't seem to be working. Yeah. So I have 1/8 times, can someone do the interior here? 1 squared plus 2 times 1.25 squared plus 2 times 1.5 squared plus 2 times 1.75 squared times plus 2 squared. 1/8 times some decimal. What did you get? 18.79? Okay, divided by 8 or times it by 1/8. Is that all the digits? Those are all the digits. Did you guys get that? Okay, practice, guys. Real quick. If you look at your trapezoids, is this an overestimate or an underestimate? Overestimate. Because why do you suppose that is? Is it because it's increasing? Is it because it's concave? Let's come over here. Do I have space anywhere? I'll go here to the margin. So look, check it out, guys. Let's just test it out. Let's see if it's anything to do with increasing. Do you think it's increasing or do you think it's concave? All right, let's see. Let's try it. Let's try increasing concave up, increasing concave down. Let's try it. Point. Slightly overestimate. Do you guys see that? Point. OMG, what did we just observe? So does it matter? Bless you. You're right. So for trapezoids, does increasing, decreasing matter? No, because look, both of these graphs are increasing. Increasing, decreasing does not matter. What matters for concavity? What matters for trapezoidal sum? The concavity. Put that as a note. Over, under, estimate for trapezoids depends on concavity of curve, which is different from the LRAM, MRAM, RRAM. Well, LRAM and RRAM specifically. Because an LRAM and RRAM concavity doesn't matter. It's increasing, decreasing. Chav, I don't understand. You'll see. We'll get there right now. All right. Example 2. On the interval -2 to 4, if 3 equal subdivisions are used, what is the trapezoidal approximation of this? All right, guys. I hope that we have an idea how this graph looks. You don't have to be an expert. It doesn't have to be perfect. All e to the x's, all of them, regardless of your coefficient in the front, all that does is vertical stretch or compress, look like this, all of them. Cool or not cool? So I'm going to exaggerate it, and we're going to find it. So here is me exaggerating it. I'm going to say here's -2, and I'm going to say here's 4. I want 3 equal subdivisions. So I'm going to come over here. I'm going to say my delta x, which is the same as my height. Bless you to the 3rd power, or 4th power, I think. The record is 11, I think, by Malena Flores. You know what? We'll send this video to her in a little bit. Let's see. 4 minus a -2 divided by, how many do we have again? 3. I'm getting my height of each trapezoid because they're, I know we said not to use the formulas, right? But we'll get one in a little bit that, yeah, there it is. We'll get one in a little bit that have different heights. So 6 divided by 3, so that's 2. So here's my first trapezoid. Bam, bam. And then smack in the middle of that, 2. Here's my next trapezoid. And here's my next trapezoid. It's kind of like on the side. Do we see that, guys? All right. The height of each trapezoid is 2. So I'm going to go on the outside. I'm going to go 2 divided by 2, open parenthesis. Chav, what are you doing? I'm doing this, guys. I'm doing this. Height over 2. I'm doing this guy right here. I'm doing 3 trapezoids, so I need 4 points. And my point depends on, what's my equation? That guy right here. That's the height of the function, or the base of the function. So the first one's going to go parenthesis e to the -2 over 2. I guess we could have also factored that out. Plus 2 times e to the 0 over 2, close, plus 2 times, this is a function, guys, e squared over 2. Ask me. Ask me, miss. Are you sure? E to the 4th over 2. I have 3 trapezoids, so I need 4 points. 1, 2, 3, 4. The interior points have a 2 in the front. From Chav, where did that come from? From this formula, see? 1, 2, 3, 4. That's all I'm doing. Let's see. I noticed that I can cancel out. We'll check right now what the answer choices up there. This 2 and that 2 cancel. That 2 and that 2 cancel. And that's it. So I'm going to look first for this answer. And I don't see it the way it's written there, because notice e to the -2 there and e to the 4th don't have a half there. And let's see. Will this one work? Nope. Let's see. Will that one work? Okay, I see it. Factor out a half. You see this 2 down here and that 2 down there? So if I factor out a half, so here's what you're going to have. 1/2, parentheses, so this is going to be e to the -2 plus, remember I factor out a half, so that means I need to make this 2. Because when I distribute the 1/2 times 2, it's a 1. Okay, I'll wait. Yeah. Yeah, look, guys. You see that half in the bottom and this half in the bottom? I factored these out. This is a 1. So I have, that half is from this one and this one. But this one doesn't have a half. It just says e to the 0. So when I distribute this half, I better get just e to the 0. 1 half times 2, I just get e to the 0. Same thing with this one. That's e squared, so I better have a 2 in the front. So when I distribute that half, 1 half times 2 is e squared. Does that make sense? Okay. Yeah, I know, guys. I know. It's just algebra. Plus 2e squared plus e to the 4th. Close. Child, why are those two are in the front? Because I factored out a half. If I were to distribute this, you'll get the purple line in the top. So there it is. Now, let's see. Now is that one in there? Yeah. Cool or not cool? Okay. All right, check it out, guys. So now we got something. The function f is continuous on the closed interval 1 to 7 and has values that are given in the table. So here are the values. Using the subintervals 1 to 4, 4 to 6, and 6 to 7, what is the trapezoidal approximation of this? So they want me to get that. Guys, we don't have even trapezoids. Our delta x's are not even now. This is the height. Height of first trapezoid. Height. Here's my height of the second trapezoid. Remember, it's in the side. Here's the height of the third trapezoid. There's my 3 trapezoids. Do you guys see that? All right, so I'm going to write, and this is my quote-unquote base. The 10, the 30, the 40, the 20. Those are your bases. Those are your bases. You guys are visual learners, so let me go ahead and see if I can draw this. I'm going to say 1, and I'm going to say 110 is right here. Not to scale. Not to scale. And I'm going to say 430 is right here. And I'm going to say 640, not to scale, guys. 640 is right here. And then 720. 720, well, let me make it closer. 720. All right, so here's how my trapezoids look. Boom, boom. See, like that. Trapezoid 1, trapezoid 2, trapezoid 3. Cool? All right, so here it is. First trapezoid. So this is my base. This is your first base. This is your second base, what you see in purple. So I'm going to go parenthesis 10 plus 30 times my height. What's the difference between 1 and 4? 3 divided by 2. That's your first trapezoid. Plus the second trapezoid. 30 plus 40, that's a parenthesis, times, what's the difference between 4 and 6? 2 divided by 2, plus, and then the last one is 40 plus 20 times, what's the difference between 7 and 6? 1 divided by 2. There it is, guys. Now we're just going to add them up. So let's see. 30 plus 10 is 40. 40 divided by 2 is 20. 20 times 3 is 60. Plus, all I did was this one. That one is this one. Let's see. The 2's cancel out right there. 4, 5, 6, 7. 70. That's that one. Plus, 40 plus 20 is 60. Divided by 2 is 30. That's that one. Let's see. 60 plus 70, 130 plus 30, 160. 120, 130, 160. Yep, there it is. We did it. Yeah, it's just geometry, guys. Cool or not cool? Okay. All right, this is just a quick review because we were talking about the overestimate and underestimate. Check it out, guys. This is what I love this. If a function f of x is strictly increasing from a to b and you do an LRAM with equal subdivisions, LRAM will produce an underestimate to the actual value. All right, because remember, this is the exact value. Do a visual. Look, increasing. And it doesn't matter concavity, guys. A, B. How many rectangles should we put? 2? Okay, 2. And then I'm going to do another one. But I'm going to set up concave down, concave up. I'm going to do concave down. So you guys can see it doesn't matter. The concavity doesn't matter. And I'll just do 2. Do you guys see how it's an underestimate? See, concavity does not matter. Make sure to put that there. Concavity does not matter for LRAM. increasing, decreasing does. If f of x is strictly increasing and you do an RRAM, we'll produce an overestimate. So here it is. And here's my curve. Let me do a better curve. Concave up. And we'll just do two rectangles, RRAM. So point, point. See? They don't have to be perfect, guys. You do not have to be perfect. RRAM. See? Again, same thing. Concavity does not matter for RRAM. Increasing, decreasing does. You can see it's an overestimate. Yeah, I'll slow down, guys. I'll slow down. Check it out. This one's decreasing. So I'm going to decrease. I'll do both of them. Decreasing concave up. And what do they want? LRAM? LRAM. See? Let's do decreasing concave down. Concavity does not matter. Increasing, decreasing does for LRAM and RRAM. Same thing here, guys. RRAM decreasing. So here it is. Let's do an decreasing, and now we're doing RRAM. I know, my rectangles suck. I got a D in art. I really did get a D in art. That's not me just saying that. At one time I was really embarrassed, but I don't care anymore. So you shouldn't feel bad if you get a D in like calculus, because I got a D in art. How do you get a D in art? I don't know. I made it happen. I'm not telling you to go get a D. Don't. But you know, I should have advocated for myself. I didn't know enough. All right, cool or not cool? So let's reiterate, guys. For LRAM and RRAM, does concavity matter? No, just increasing or decreasing. What about for trapezoidal? Concavity matters for trapezoidal. Are we cool? Okay, that's the big thing. All right, guys, I don't think this is a real AP question. Real AP question. I think it's unfair for me to just give you this when we just started learning this. So we're going to skip it momentarily until we get more experience, because I don't want you to get frustrated right now. So skip momentarily. But there it is. There's a real free response question, guys. Okay, so right now all we're going to do is practice. And then once we get really good, then we'll do a real life situation like this with position, velocity, acceleration. All right. So let's see what it says. This is coming from Delta, I believe. Selected values. What is the midpoint Riemann-Simon approximation for using 4 subintervals? Okay, so they want me to use MRAM, middle. So all you're doing is rectangles, guys. Width times height, width times height, width times height. So let's find out. Let's see. From 4 to 8, that's my first rectangle. 8 to 12, that's your second rectangle. 12 to 16, that's your third rectangle. 16 to 20, that's your fourth rectangle. All of them have a delta x of 4. Do you guys see that? No? Because they told me to use 4 subintervals. So 20 minus 4, the upper minus lower, divided by 4. So 16 over 4. So your delta x of each rectangle is 4. Maybe I should have done that first. So 4 plus 4 is 8. So here's my first rectangle. Do you guys want me to like plot some points? Okay, let me plot some points. So this is not to scale. Not to scale. Okay, look, I'm just going to pretend. 4, 14. I'm going to say 14's right here. Point. And then I'm going to go 6, 20. Point. I'm just going to do the first one, guys. I'm going to go 10. 8. 833. And I'm going to say 33 is over here. Point. Okay. I just did the first one. Here's my first rectangle. What did they want me to use? Midpoint. So look, these are the midpoints, the ones in green. The ones in green are the midpoint. So here's my first rectangle. They want me to use the midpoint. Boom, boom. There's my first rectangle. See? And I just keep doing that for all of them. So I'm going to go ahead and write it right here, guys. The delta x, the height of the first rectangle, or the width times height. Width is 4. And then the height is the one in the middle. The x equals 6 is the middle. So 20. That's my first rectangle. Do you guys see how I did it? Silali, tell me. Okay. Here's my second rectangle. From 8 to 12. That's my 4. That's the width of 4. And I'm using the one in the middle because they say MRAM. The height is 37. So I'm going to go 4. All of them have a 4, right? Times 37. Because I'm using the one in the middle. Plus the next one. The next one from 12 to 16. So again, it's 4. And I'm using the one in the middle. 42.5. And then the last one. 4. Because the difference between 16 and 20. And I use the one in the middle. 37. All I'm doing is rectangles, guys. Width times height. Width times height. Chavez, how do you determine what's the height? They told me middle. They told me midpoint. So what's in the middle between 4 and 8? 6. What's in the middle between 8 and 12? 10. What's in the middle between 12 and 16? 14. What's in the middle between 16 and 20? 18. And you're using the y value for the height of that rectangle. Does that make sense, guys? Okay, take your calculators. My calculator's not working. Let me see. Let me see if it started working now. Oh, it did. It did start working. Okay, well, still, take your calculators and hook me up with this number, guys. Because there's decimals there. I don't do decimals as good as you guys do. 546. All right, there it is. Happy face. Obviously, we're finding area under the curve, so eventually this starts to mean something when we start putting units to it. All right. So you guys help me out. We're doing a right Riemann sum. How many intervals do they want? 5. Let's see. Are they even intervals? No, they're not. Indicated by the table. So these are not the same spaced out delta x like these were. These, they want you to use these specific ones. Here are the 5. 1, 2, 3, 4, 5. All I'm doing is width times height. What's the width of the first rectangle? Yeah, say it loud and proud. Not everyone at the same time. What is it? 1, yes. What's the height? Do I use the 11 or do I use the 9? Why are you using the 9? Because it's right. It's the right Riemann sum. Perfect. What's the delta x for the second rectangle? 1 again. And what am I using? The 5. Plus, what about the third rectangle? 3, 5 minus 2, guys, times 15. What's the fourth rectangle? 4 times, and then the last one, what is it? What's the width? Yes, 2 times. All right, add them up. Add them up. Hundred and what? 93. Yeah, that looks about right. Don't worry, guys. We're almost done. I think this is the last one, and then we'll set you loose. 3 subintervals of equal length. A right Riemann sum. Maybe I might do a visual for this one. Does everyone know how 2 ln of x looks like? No? Okay. 2 ln of x has a vertical asymptote on the y-axis at x equals 0. And it looks like this. Where it goes through the point 1, 0. They want me to do 3 equal lengths. I'm going to say that's 1 and here is 7. So I'm going to find out my delta x by doing this. 7 minus 1 divided by 3, because they want 3 trapezoids, or no, Riemann sums, right Riemann sums. So 6 over 3, so 2. 1, 2, 3, 4, 5. Okay, so there it is. There's my 3. So 1, 2, 3, 4, 5, 6, 7. All right, right Riemann sum. So here's your visual, guys. Boom. Here's your second. Here's your third. We're still okay? All right, that's it. We just figured that out. So how do we figure it out? All the delta x's are 2. 2 times the height of the first one is dictated by the 3, the x equals 3. So 2 ln of 3. Mr. Chavez. Okay. Thank you. That's Reese here leaving. Plus 2 ln of 5 plus 2 ln of 7. Whatever this adds up is the approximate. All I did was width times height, width times height. The height is dictated by this x value, and you're looking for a y value. So remember, your function is this. So whenever you plug in a 3, that's going to give you the y value of that. What's up, Pina? Ask me. No, ask me. I want you to. I want you to ask me. Okay, I won't do that again. Sorry. Yeah, I know. It's because my sister hyped me up with me singing. So now that's what I get. I make a fool out of myself. So don't ever hype me up when I sing, guys, because then I'll just continue singing. All right. Any questions, guys? Because we're doing RRAM and I'll change the color. This width right here is a 2, and then this height is this guy right here. That height is 2 ln of 3. So width times height. Same thing. No. Oh yeah. Did I not put a 2? Dang, I thought I was putting a 2. No, I think that this is my width. That's my width. Yeah, no, it needs a 2. I'm missing a 2. Yeah, the original equation is 2 ln x.
Oh, I thought you factored out the 2.
No, that 2 was my delta x. I'm missing. Yeah, no, good thing you told me. I was wrong. Now it's right. Just put a 2 in there. Because of height. Oh, if you factor out the 2, then that becomes a 4. Yeah, now it's correct, guys. Thank you, Kanduru. If not, I would have been leaving you guys on a hang there. Okay, now it's correct. Now it's correct. Width times height, width times height. Any issues? Okay, practice, guys. Practice, and then tomorrow, if it's okay with you guys, we'll use half the time for calculus. Or we'll see. I need to talk to Luna.
What classes do we have simulations? There's only 9 and 3.
First and ninth? Okay.
That's it the whole day?
Yeah, but you're going to be tired from all testing. Okay, this is a right Riemann sum, so I'm going to go new problem, right Riemann, new problem, right Riemann. Okay, here we go. This one says trapezoid. So it says, let it be the function graph below. If 3 subintervals of equal length are used to draw trapezoids, whose areas represents the trapezoidal sum approximation. All right, so 10 minus 1 is 9. 9 divided by 3 is 3. So each delta x is going to have an interval of 3. Width of each interval, 3. So there it is. So how do you do this? The left and the right have to touch the curve. So there it is. Make it go all the way to bam. And then this one right here, make it touch the curve. Oh, okay. You're just going to have to do it. You're going to have to be careful. See, when I click on that, it goes to the other one here. There we go. And I think I got them all. And there it is. And what else do we want to do? The shaded area above represents trapezoidal sum. You can see it's an overestimate, over approximation, compared to the real one, because the function is, because remember, trapezoid deals with what? Concavity or increasing, decreasing? Concavity, because it's concave up. And there it is. Over approximation because it's concave up. Submit. And there it is. LRAM, RRAM deals with increasing, decreasing. Trapezoid deals with concavity. Cool or not cool? They're rectangles. Yeah. And then you can also see why LRAM plus RRAM divided by 2 gives you the same answer. Because you're doing the leftmost and the rightmost, right?
And if it's increasing, then it's over approximation.
For which one? LRAM? LRAM will be an under approximation because it's all below the curve.
So RRAM.
RRAM will be an over.
Because it's increasing.
Because it's an increasing using the rightmost point for the rectangle. Does that make sense? Draw a little visual to help you out as well.